Let's say if there are the two distant planets where the life is 100% impossible, and I have to compare while living here on Earth, I have to compare which one of them is hotter by just seeing it. This question is going to address this thing. So let's say these are the two planets, planet X and planet Y. What question says that the planet X is less hotter, and by the way, both are the black body radiators. Black body radiators means their emissivity is 1, and it means that all the energy that these two absorbs, they radiate all of them. This is what it means, black body radiation. So it means that both of these planets are emitting, releasing, radiating all of their energy in the form of radiations, and we are given the intensity and wavelength curve by in these options. So, and according to the question, the planet X is less hotter and the Y is more hotter, means the Y temperature is more. So the Ty is more than Tx. Well, first of all, I will explain you what the intensity and wavelength graph tells us. According to the Stephen Boltzmann law, and according to the modern physics, that all the energy that is radiated from the planet is not radiated in a form of single wavelength. It is radiated in the entire electromagnetic spectrum, and which you can see easily by looking the different wavelengths. And what is special is that this wavelength, which according to this graph has a maximum intensity, I will call it maximum wavelength. Why? Because this is that specific wavelength of light which carries the maximum portion of energy released from the planet. And just last thing, the area under the graph tells us more interesting thing, and it tells us that how much energy overall is radiated from the planet. So if a one planet have a higher temperature, so obviously its area must be larger because it will radiate more energy, and that is actually we know that the power is proportional to the temperature is power 4 according to the Stephen Boltzmann law, or you can also say luminosity is proportional to the T raised power 4. And now, if I connect this intensity wavelength graph with the planet situation, then remember that this planet is going to release the minimum wavelength, means the gamma ray, to the maximum wavelength electromagnetic, which is a radio wave and also visible light. And for this reason, I'm going to show you all of them to you. So this was just possible for me. So I have tried to show you that whole electromagnetic spectrum is radiated from both of the planets. Now, according to the question, they say the planet X is less hotter, and the graph is actually shown by the dotted for X. You see that the dotted means that in all of these options, this dotted curve is actually representing the intensity wavelength curve for the planet X. And what will be for the planet Y? Let's take advantage of Wien's law. So what the Wien's law says that it relates the temperature and the wavelength. Which wavelength? The maximum wavelength, which I mentioned you here. The maximum wavelength doesn't mean it has a maximum length. No, means that it is that light which carries the maximum energy. So it says that the product of the temperature and the maximum wavelength is constant, and that constant is 2.9 times 10 to the power negative 3 meter Kelvin. So that is constant. It means that the maximum wavelength and the temperature is inversely proportional. So like this. So if you use this information, what information that we know that the temperature for the X is less than temperature for the Y, which means that now logically we can derive the result that the maximum wavelength emitted for the X would be larger than the maximum wavelength for the Y. It means that, so, dear students, let's apply now the results that we have learned. Now, I'm going to compare the two. So, I'm saying, let's say this is the graph for the X, and this is the wavelength for the X, lambda X. Now, what we have learned that the wavelength of X must be larger. So it, and secondly, the temperature of Y is more. That's why the planet Y must release more energy. So it should have a more area under the curve. So which directly leads what, where it does it lead to? Don't you think it leads to exactly something like this curve? Because if you see that, the area under this curve is first of all more than the area under the curve for the x, which means more energy is released. And secondly, dear students, you can compare the wavelength for the y is obviously more less than the wavelength for the x. So it means that this is for the y, and you can easily identify which one should be our right answer. So none other than option D is the only possible right answer for this question.